Hey everyone, welcome to Code World, and today we'll be going over LeetCode number 11, Container with Most Water. This is another problem off the Blind 75 list, which is a list of LeetCode problems commonly asked during coding interviews. So in this problem, you're given an integer array height of length n. And basically, this array height is formed of numbers, and each of these numbers indicates the length, the height, of a specific line. So we can see, for example, in this example, at the index 0 of this height array, we have the value 1. Therefore, the first line in this graph is a line with height 1. Following this, we have the value 8 in our height array, and therefore, the next line in our graph has a height of 8. Following this, we have a value of 6 in our array, and therefore, in our graph, we have a line at index 2 with height 6. And the same can be said for the rest of the values in the array, forming respective lines. Basically, in this problem, what we want to do is return the container that can be formed in this graph containing the most water. Or in other words, we want to return the greatest rectangle that can be formed in this graph with the greatest area. We have, for example, a container or a rectangle, which is depicted here in our example, and this is a blue rectangle. It has as its left side the line at index 1, which has a height of 8, and on its right side, the line at index 8, which has a height of 7. So we can see that because we're filling these rectangles or these containers with water, the height of the rectangle being considered must be the line at its side with the lowest height. In fact, if we consider the height of this rectangle to be 8, then what would happen when filling with water is that it would flow from the right side out of the rectangle. So therefore, we have to consider the height as 7, given by the line at index 8, which is smaller. So we know that this rectangle therefore has a height of 7, and instead its width will be the difference between the two indices of the lines. So we have index 8 and index 1. Therefore, the base will be 7. If we were to calculate the height of this rectangle, we know that it would be 7, whereas the base would be calculated by doing the subtraction between the indices, so 8 minus 1. And in multiplying base times height, we would get the area, which is 49. And this is the amount of water that can be stored in this container. In fact, this is the greatest rectangle possible that can be formed with this specific graph, and we return 49 as the output, as we can see in the example over here, where 49 is returned. There are two different approaches in solving this problem. We can solve first using a more brute force approach, which takes O of n squared time complexity, and considers every possible subarray or every possible rectangle which can be formed using these lines. For example, we would start considering the left side as this first line, and take a look at all of the rectangles which can be formed using this rectangle as the left side. So we have this rectangle going from line 0 to line 1. Then we have the next line going from the next rectangle going from line 0 to line 2. And this would continue for all of the rectangles. For example, we would then have the rectangle going from line 0 to line 3, and so on. We would calculate the area of all of these rectangles and find the one with the greatest area. After doing this for all of the rectangles having the line at index 0 as its left side, we would do the same for the line at index 1, calculating first the area of the rectangle formed between line 1 and line 2, then that between line 1 and line 3, and so on. After doing this, we would come out with the rectangle with the greatest area. This is the code for this solution. We see that we would need two for loops, one for a left pointer indicating the left side of the rectangle we're currently looking at, and one for a right pointer indicating the right side of the rectangle we're currently looking at. Because of these two nested for loops, we would have an O of n squared time complexity. In these for loops, what we do is basically calculate the base and the height, and then the area, and each time we come up with a new area, we would check to see if we have beat our previous max area. And if we have, we would store this new max area. Now we could approach this in a more greedy manner, taking consideration of the fact that we want the rectangle that we return to have the greatest area possible. So by using a more greedy approach and keeping the base and height as largest as possible, we will be able to optimize the solution to be instead a linear time complexity. So time would be O of n. The way we would do this would be to start out our left and right pointers indicating the left and right side of our rectangle as far as possible. So we would have, for example, our left pointer starting here at index 0, and our right pointer starting here at index 8. The reason we do this is because this would allow our base to be as largest as possible. We would then consider the rectangle formed by these two lines and calculate its area. So for example, in this case, what we would do is we would consider the base to be 8 minus 0. The height would be the smallest value between 1 and 7, so it would be 1. And we would calculate therefore the area to be 8. We would then move on to the next rectangle by taking consideration of the fact that we want to keep the height as largest as possible. So we look at the two heights of the two sides so far, and we have at the left pointer a height of 1, and on the right pointer a height of 7. Because of this, we would decide to move our left pointer to the next line in order to keep the height largest as possible. We would then calculate the rectangle that is formed by these two lines, and we would see the area formed by these two lines. So once again, we would have an index of 8 from the right side minus 1 from the left side, and this would be our base, and we'd multiply by 7, which is the height of the smallest line. In this case, we'd get an output of 49. And furthermore, when considering the height of the two lines that are currently being taken into consideration, we would this time move the right pointer to the next line because we want the height to remain as largest as possible, and we have a height of 8 on the left side, so we'd want to keep that. This would continue until the left and right pointers cross, where we keep moving the right pointer by taking into consideration which line has the lowest height. So again, in this case, between 3 and 8, we would choose to move the right pointer. And each time we would calculate the area of the rectangle formed. When we have a tie, we can decide to move any pointer we want. So in this case, we would keep moving our right pointer until it reaches where the left pointer is. And once the two pointers cross, we can finish our algorithm. Because we are only traversing the array once in this case, even though we are using two pointers, this will be an O of n time complexity algorithm. So we're ready to go back to LeetCode and code this up. So the code for this optimal solution is actually not too long. We're going to start off by calling out our left and right pointers. So we said our left pointer is going to start at index 0 of this height array, and our right pointer is going to start at the last position of this height array. Afterwards, we're going to declare our max area variable, and we're going to start it to 0. And then we're going to start our while loop, which will continue until our left and right pointers do not cross each other. Each time we're going to calculate a current area, and we know that the current area is going to have as the base the right pointer minus the left pointer. And the height will be the minimum value between the height at the left pointer and the height at the right pointer. Each time we're going to see if we have found a new max area by taking the max value between the current max area and the current area. Afterwards, what we want to do is move our left or right pointer based on which height is smaller. If the left height is smaller, we want to move the left pointer. If the right height is smaller, then we want to move the right pointer. So we can say if height at left is smaller than height at right, then what we want to do is increment our left pointer. Otherwise, if our height at left is greater or equal to, we could just decrement our right pointer. At the end, what we do is return the max area. Now let's make sure this runs. And we can see that it works. I hope you found this video helpful. If you liked it, please give it a thumbs up and subscribe to my channel. I'll see you on the next one.